In this video, we're going to discuss reliability. So what do we mean by reliability in a measurement? So when we say something's reliable, we say that it's stable or consistent, so that there's a consistency in the measurements produced by a specific procedure. So that if we measure something today with a certain tool, when we measure it again 6 months from now, we should get the same result. So there's that stability or consistency, unless, of course, something's intervened or changed. So when we talk about this concept of reliability, we're assuming that the variable, of course, that's being measured is constant, that it shouldn't change over time. If there's something that should change over time, then this idea of reliability doesn't matter. We also assume that any inconsistency of measurement comes from error. So some sort of error that's been made, and again, not because the variable should change. So that's when we're talking about reliability, it's important to keep that in mind, because the measured score is really the true score plus any error. And so the idea is, how much error does that measurement have? If it has too much error, it becomes an unreliable measurement. So now we want to talk about what could these potential sources of error be. So the first one we're going to talk about is observer error. So this is where the person that's taking the measurement, they introduce some sort of simple human error. So of course, this idea of observer error really only comes into play when we're talking about a human that's making some sort of subjective type of measurement. For example, I was talking to someone the other day, and they were questioning the reliability of the advanced placement, the AP exam scores. She said that her daughter had only gotten a 2 on an AP test, and then she took it the next year and got a 4. She didn't think that the score would improve that much, and she questioned that maybe it was the rater. She didn't think that her daughter had really, she'd taken the AP class, took the test, didn't pass it. She didn't feel that her daughter had studied an overwhelmingly amount to go from a 2 to a 4. So it could be that it was an observer error. I've learned a little bit more about AP testing and how those are done. And basically, they hire people who are at the college level teaching these classes. I'm not sure if they hire high school teachers or not, but they hire, like if I was teaching Psych 101, I could be an AP exam rater for those AP tests. But they give you a rubric, and the rubric's pretty strict. And basically, this year was different because of what's going on. But in most years, they fly thousands of people to hotels in various parts of the country, and as a cohort, you're all grading those AP exams at the same time. You all have the same rubrics to grade them by, and so on and so forth. But when you have individual differences, there is some subjectivity to that. So in addition, there could be environmental changes that induce error. It's really hard sometimes to attain the same identical circumstances. So maybe in one room you have students taking some sort of test on a computer, but you have this old-fashioned computer, and then another end, which is faster processing and whatnot, and in another room you have a nice new modern type of computer. Another example is in 3rd grade, my daughter took the OLSAT, which is used to place students in GATE. Now she's really intelligent, but she didn't test well. Her scores weren't horrible, but she didn't test into GATE. So the next year she went ahead and took it, and her scores were a lot higher. Now we did do some interventions. We went over the test with her because we just kind of did a little practice to help her. I don't think that's why her scores improved. I think it was the difference in the first year when they do the practice. The teacher goes through it and helps them understand if they have any questions, because there's no directions on this test. You just have to know what's expected. And so her teacher in 3rd grade wasn't a great teacher, but a little scatterbrained. And so I think that when she took the practice test the next year with the person who is paid to administer this test, probably was a little bit different of a practice test situation, so that then she could do better. So there's an environmental difference there. There could also be changes in the participants. So the participant may change between measurements, maybe the degree of focus that they had. Maybe they were tired one time and not tired another. On a test of aggression, what if something happened before that made the person angry, and the next time that didn't happen? What if someone took a math test and then they took the same math test a month later and they scored much higher? You know, could there have been some intervention in between testing? So there can be things that change with the participants that can introduce that error and make something seem unreliable, but maybe it really isn't. So now we're going to talk about types and measures of reliability. So the first is successive measurements. So this is when you use a measurement one time and then you subsequently now we're going to talk about types and measures of reliability. And first is going to be successive measurements. So this is when you use a measurement and then you use it again later on. So those are successive measurements. And so the type of reliability that looks at is this test-retest reliability. So you test the individual and then you test them later on. So it's comparing scores of two successive measurements on the same individuals, and then you correlate the scores. You look to see, are those two test scores correlated? So you have the test scores at time 1 and the test scores at time 2, and you look to see if they're highly correlated. It suggests you have a high test-retest reliability. Then there's simultaneous measurements. So simultaneous obviously means at the same time. So this might be inter-rater reliability. One type of reliability that can be done looking at simultaneous measurements is this inter-rater reliability. And this is when you have agreement between two observers who simultaneously record the measurements of the behaviors. And you're going to have, in the operational definition lab that you did, you had the opportunity to kind of see this idea of inter-rater reliability and how that's why that operational definition can be very important. So again, you have two different people using the same measurement, using that to record some sort of behavior, and then you look and see, are those behaviors, are those scores, those two observer scores, is there a high correlation? If there's a high correlation in those simultaneous measurements between those two raters, it suggests a high inter-rater reliability. So that's, again, two different people using that measurement at the same time. You compare those scores. Then there's looking at internal consistency. And this also could kind of be a simultaneous measurement. And this is split half reliability. So basically you split the test in half and you compute a separate score for each half. So you take a single test, you split, so 1 through 10 is one half, 10 through 20 is another half, and then you take the results of those scores and you again look at a correlation. So it calculates the degree of consistency between the two scores for a group of participants. So the scores on 1 through 10, the scores on 11 through 20, they should be highly correlated if you have high split half reliability. So it's important to note that reliability is a prerequisite for validity. So a measurement procedure cannot be valid unless it's reliable. So you can't have something that's valid unless it's reliable. You can't have something that's measuring what it's designed to measure if it isn't consistent over time. Now, a measurement can be reliable without being valid. So you can have something that's consistent over time, but isn't really measuring what it's designed to measure. So the consistency of measurement is really no guarantee of validity.